Good evening, everyone. I want to take a moment and welcome you to EdTech Maryland Meetup. How will EdTech platforms leverage data in 2022 and beyond? We are here well, first let's cover the agenda. So just welcome. And we have a moderator and an expert panel here to talk about how to use data and platforms. The panelist discussion will last for approximately 40 minutes. You can post any questions or raise your hand in the chat features that you have available to you. So please feel free to take advantage of those as the panelist discussion is happening. We'll be happy to answer those questions. We'll also have time at the end specifically for questions and answers for about 20 minutes. At that time, we'll bring everybody in as a presenter so everybody can see everybody else for a little bit of networking time. So without further ado, I'd like to introduce Ed Mullen. He's our Senior Management and Fractional CIO for Think. He's founder of Technology Executive Peer Advisory Network called TPAN. It's a great way to network with other CIOs, CTOs, CISOs, and problem solution solve. He's also the Executive Director of Baltimore Robotics Center and Chapter Associate for Enterprise Growth. In addition to Ed, we have on our panel this evening, Andrew J. Hampton. He's Assistant Professor of Psychology and Chair of the IEE Standards Association Working Group for Adaptive Instructional Systems. We also have Phil Horowitz, who is the Chief Architect at JBS Custom Software Solutions, and an industry veteran with over 20 years of experience. And lastly, we have Russ Lewinter. He's the head of EdTech GovTech Ideation at AWS. He's a PMP, CSPO, head of EdTech GovTech Ideation, and is definitely an expert on this topic, and we're very excited to have him on our panel this evening. All right. So it looks like we've lost our moderator. So I'm going to go ahead and, I guess, moderate the session.
So, Laura, can you hear me?
I can hear you, yes.
I'm in the studio. I'm not sure.
All right, let's see. Let me move you to return to scene.
There we go.
You are. Perfect. All right, so I'm going to hide myself and we'll commence with the session.
Okay, and folks that are on the panel, if you want to take more time and talk about, why you're passionate about this topic, feel free. But I was going to sort of kick it off to Drew and ask, what is the significance of big data in the educational sector?
Yeah, that's a really big question. And the simplest answer is that we really don't know yet. It is pure potential. It is a massive tool that we didn't really intend to build. So most of the data I think that we're trying to leverage right now came about because it was easier to put assessments and to put quizzes and to put exercises online. And what do you know, when you do that, it's really easy to gather data. But it wasn't created, it wasn't kind of generated with the expectation of using that as the primary tool. And we're getting to a point now where we have so much information, so much raw potential about students, about learners of every age and every sector across the world, that we recognize we can do some really interesting and important things with it. We just don't really know what those are yet. We have lots and lots and lots of ideas, but putting those into practice is a much bigger question and challenge. A lot of the things that we have done already have come from sectors outside of education. So like Duolingo can recognize the time of day that you're most likely to be doing your practice and send you an email or a notification then. But Peloton can do the same thing. And there's plenty in common with those kinds of apps, but it's not really the kind of thing that's going to get educational psychologists and people in the EdTech sector excited. There's so much more that we can do. We're kids in a candy store at this point.
Right. So I think there's a lot of opportunity to improve the educational system. You want to give any foreshadowing of your or predictions, forecasting? What do you think is going to be the breakout area of improving education using data?
Yeah. So making educated guesses is like the favorite pastime of certainly the academic sector in this. We've seen ways that it has actually made a difference already. So it doesn't do it on its own. It's not just like throw data at a problem and it's going to be fixed. But we've seen aspects of different theories through educational history that have been tested. So we've known, for example, learning styles. It's a kind of intuitive and a really, really difficult idea to dispel that I'm a visual learner, I'm a verbal learner. If you test those things experimentally, they disappear like right away. And we've kind of known that through relatively small scale testing, that people all just tend to do well if you reinforce in a bunch of different ways. They have preferred learning styles, but they don't perform better. And with massive amounts of data, we can really effectively dispel the idea that someone is a verbal, visual, whatever kind of learner, and present the information to them in a way that we know is going to work. But we have to have that theory in order to test it. Where we could go in the future is coming up with new theories. We can ask questions that we wouldn't have had any kind of capacity to test in the past, not even small scale, and just immediately ramp it up without even kind of inconveniencing people to come into a lab and do a study. It's out there. We just run the test without anybody knowing or being bothered by it. In terms of like what we could do, for example, getting rid of assessments, getting rid of standardized testing is completely plausible. Every time you have an interaction with a software program, with educational technology, that is an assessment. So instead of one giant 3-hour assessment, we have, 100 assessments over the course of a day or a classroom session. Whatever the level of granularity of analysis you want to have, we potentially can do that and create a much more comprehensive picture of an individual learner or of learning in general.
Getting rid of the SATs? That's crazy talk. But that, as you were talking about the Peloton example, I'm like, oh my God, like the ability to do individual, very highly granular data assessments is an intriguing prospect. I was going to kick it over to Russ. Can you give us some insight into what trends you're seeing in EdTech organizations?
Yeah, so a lot of it is around maybe they don't even know where to start with data, or they don't have enough data when it comes to even learning assets. So a lot of times these major publishers, they have all this content, but they don't actually metadata tag it. So a lot of times we come in, we're working with a lot of those companies to understand that this is a building block to creating recommendation engines that utilize the data that Andrew's talking about, that every time you're taking an assessment, you're generating data, you're generating pieces of content that we could then use later on. So we're working with a lot of customers on that. It's almost a crawl approach that we'll probably talk about a little later. But I alluded to recommendation engines. We have lots of folks who are looking at ways to truly prescribe content, personalize it, because not everyone learns the same. Not everyone learns in the exact same sequential pattern that others do. So we're looking at it in that way, personalized education we're seeing. We're also seeing recommendation engines of just using data to understand preferences and how students, like what certain content they should be looking at that maybe they're not, because they're always focused on one area. We see it in early education. And I use an example a lot of times. I've got a 6-year-old who's obsessed with animals. He's always focused on reading about animals. Well, we can use recommendation engines and that data that we have to be able to say, hey, this animal lives in this biome. This biome was discovered by this explorer, and it really expands their knowledge as well. And then one area that I'm really passionate about, and when I worked for Pearson for many years, we were looking at predictive learning analytics and early intervention systems. So we've got all this assessment data. We have all this content from years and years of teaching a course a very similar way. And how can we use that data to determine different triggers that could potentially trip up a student that may not allow them to complete with a C or better in college? And really just using that data to make better informed decisions for students, for faculty, for administrators, and so forth. Those are just some of the areas that we're seeing quite a bit of trends in the data space. But to the point that we talked about, there's just so much that we can do with data that we're just scratching the surface. And customers have all this data and they don't even know where to get started. So that is one of the areas that we're focused a lot on at AWS.
So Russ, you have a really interesting background, and we often think about EdTech as, K-12 and higher ed and stuff like that, but you were also involved, I believe, in learning management systems for corporations and enterprises.
Yep.
Do you see those things coming together? They seem like they're siloed in a way. And as a technologist, computer scientist, I'm like, why are these people not sharing technologies and data analytics? And maybe you could give some insight into that, because you've done both, correct?
Yeah. So, I mean, that I could get myself in a little bit of trouble in that the learning standards themselves and data interoperability are still being formed. And that's one area that we're looking at, ways that how can we pull data from different systems. But yeah, I mean, we're seeing this in the corporate space. Another trend we're hearing is around upskilling, and how can we take data that they did in high school or in college and help them get the next job or different areas that they can work on. So yeah, I mean, we're starting to see a lot of breaking down of silos, but unfortunately, a lot of ed techs, oftentimes their data is here, but there's no global repository for data that others can be able to use to leverage, to analyze, and use it in a meaningful way right now. I think if that's one of my predictions, is we'll get there eventually. But I think right now it's still very early in breaking down those silos.
Yeah, it's kind of interesting that upskilling, there's a tremendous amount of talk about, the challenges for technology workforce development, for example. And one of those things is, how do we find the people that have got the juice for that? And it's like, it's probably in that EdTech data somewhere, and it would be very valuable if we were able to mine it and go, this 10% of your, school system population, you should be, once they graduated, other people want them for their programs. And it's sort of like everything's over here, and then they're reassessing them and retesting them over here. I don't know. There's all kinds of privacy issues, and we'll probably get into that a little bit later, but there's huge opportunity here.
I agree.
So, Phil, getting into the sheer size of the data being collected, how are, what is the challenge? What are current systems doing to make it useful, to turn that data into information, into insights?
Well, from a challenge perspective, there's three key areas that I found that most systems that I guess you could say in production today are having problems with, and that are kind of opening the door for discussions like the one we're having right now. And in my experience, those three things are most systems today can't handle the volume and the velocity of the data that we would like to see in modern, for lack of a better phrase, big data systems, where we can acquire all the data we need to start doing some really interesting analytics and start to dovetail off of what Russ said about some of the machine learning and some of the predictive analytics. Those are only as effective as the data that you have, the amount and the cleanliness and so on and so forth, your data sets. And systems today they have a lot of trouble scaling and performing with all the kinds of data that we want to see. So one challenge is, how do we make systems that can handle at a organic level, not just kind of bolted on some existing system? How can we get these systems to handle the volume of data that we want to do the kinds of analytics that we would like to do, and get the kind of insights we would like to see? The second thing is one of systems integration. And this ties into Ed and Russ, both what you were saying not less than 2 or 3 minutes ago. How do we get these older legacy systems talking to either newer systems or other kinds of systems? Because most systems as they exist today, they're essentially black boxes where it comes to the different aspects of how they manage their data. To get data exported, usually it requires multiple phone calls to vendors and this and that. I want this, and it needs to be in this format, and all these other things. And it's not as simple as either having somebody just programmatically call an API and grab the data, or being able to query the backend data store of the system directly on either via a user or on behalf of some other system. So the integration is really key. And along with that integration is the ability to handle semi or unstructured data. Years ago, most of our data was text and tabular in format and very easy for a lot of systems to work with. Nowadays, it's not so simple anymore. There's been a deluge now of all sorts of multimedia content, video, audio, things like online meetings where we might want to be able to find a way to leverage the content that's been surfaced through a meeting and add that to a potential curriculum or add that to our analytics and things like that. It's a far cry from being able to just ingest a CSV file that somebody exported from us. So there's handling that as well. And then the third thing, and again, this dovetails on what Russ mentioned, is that many of these systems have been in production prior to the rise of analytics in the form of machine learning and predictive analytics. So at best, many of these kinds of features that a lot of vendors tout, they're kind of bolted on afterthought, and they're not really truly integrated and woven through the system as a whole. So as such, most of the analytics, when it comes to machine learning and predictive analytics, are really on the lacking side. And it's very, very difficult to get these systems to do the kinds of things that we would like to see going forward with some of the more sophisticated types of analytics that we can do to leverage and provide benefits for the students. And I know Russ and I were chatting earlier, so and I think Russ also has some color around this as well.
Yeah, I mean, we tend to take that crawl, walk, run approach because, again, first you have to get your data in order. You need to determine where are you deficient on data. So are you getting a bunch of clickstream data as you are clicking through your platform? What does that look like? So oftentimes we'll work with customers and we'll do what we call the crawl phase, which is just investigating and understanding what data they have, what data we can use, what data is important to them. Then we move on to the walk phase. The walk phase, sometimes on the AWS stack, we have things like transcribe. So Phil mentioned the WebExes and different webinars. And how do you get that actual generated data that is video and be able to put it into a text base to maybe even improve search results when you're looking for a video asset? You're looking at that. We have services that are, I would call them more of the middle versus the really advanced machine learning aspect. Like we have AWS's SageMaker and other things that do a lot more advanced stuff. But we also have some out-of-the-box services that our customers are using to implement immediately, like Amazon Personalize. It's very similar to if you go onto the retail site and it says, hey, you bought this toothpaste, maybe you'd also like this toothbrush. But it's using a whole lot of data that we have on the back end. When someone clicks here, they go here. So that would be more of the walk approach. And then you get into machine learning where you start building custom models on top of that data and really do some super powerful things. So that's just some of the ways that you don't want to boil the ocean right out of the gate. We want you to take more of a very crawl, walk, and then run approach. Otherwise, you're going to spin the tires. You're going to be sitting here all the time wondering what's next. Like, how do I actually do this? So you can actually start taking that iterative approach towards using your data in a more advanced way.
Yeah, I think that that crawl, walk, run approach is like a great strategy. Can you give some color around that? Like maybe an anecdote or generic case study, don't have to name names, of how somebody, like what somebody accomplished doing that, how they
Yeah.
progressed?
So, I mean, probably stealing one of my thunder towards the end that I was going to say, but one case study that we have that's publicly referenceable is Discovery Education. So Discovery Education has a whole bunch of content on their website, their platform, and they created this just for you thing. They're using, this is more of the middle piece that I talked about. We have pre-baked services. They used Amazon Personalize, and it basically adapts to educator behavior. It takes in data such as what grade are they teaching, what did they use previously, and make recommendations for content to make their lives easier. And be, if you think of it like a personalized model in the future, and you're teaching second grade math the same way year after year, it knows, hey, it's June 9th. We're almost towards the end of the school year in the Northeast. Like, here's the content that you should be using in your classroom based on what you taught last year. And it really just improves the learner experience and the teacher experience as well. So that is one of the examples of, we worked with Discovery Ed to build out this recommendation engine. And the more data that you have, the better the predictions, the better the results. So that's one of the areas. And then from a crawl, walk, run approach, we're working with some publishers on, they have all this, I would say, content, really good content, but maybe their search isn't great because it's only using keywords of the file name or whatever someone put in way back when. But within that video, they're talking about certain things like Benjamin Franklin or founding fathers or something like that. So we could use, in that crawl approach, we can start using some of those pre-baked services like Comprehend to do entity extraction and keyword extraction that can then improve search results, and then can start to build that recommendation engine that we're talking about. Because without that data, without that better keyword search, they're not going to be able to get to the point of making better recommendations based off of where they're learning. So those are just a few examples, but my day is pretty much filled with these sort of conversations about how can we leverage data, AI, and ML to improve the learner experience, the student experience, the instructor experience, all the way up to the administrator or superintendent, how they can leverage the data that they're seeing to determine how students are doing within their district or within that university or school. So those are just some of the areas, Ed.
Well, all that, sort of presupposes that the data is accurate. Phil, like, how do you clean this data and ensure data integrity and make sure, that stuff coming in is not, garbage?
Well, yeah, that's actually a great question, and there's kind of two sides to this. There's the data storage piece, because one of the things that I think in terms of a mentality that would be nice to start cultivating is the fact that we need to start leveraging more of a data warehousing, data lake type approach to storing all this data, because it doesn't matter how clean the data is if you have nowhere to put it that you can expose to all these other systems and integrate with. It's not going to help anybody really. So one key piece is your data storage, whether it's object storage or something like AWS Redshift, which is something that I've used very successfully at two of the largest EdTech firms in the country. That's a key piece, and then more pointedly to your question, the actual cleaning and preparation of the data. So one thing that is very important is that we're able to build very robust, very scalable ETL pipelines for our data to pass along through. And gone are the days where we could do something as simple as set up a couple of staging tables in our database and then write a couple of SQL scripts to maybe get rid of this column or stick a formula here and add a new derived column, or make sure everything in this column is lowercase, and what do we do with missing data here? The techniques needed are much more sophisticated, because many are done in mind, ultimately knowing that we're going to feed these things through some kind of machine learning algorithm. And data prep for those kinds of algorithms is a little bit more intense than a lot of the typical kinds of data prep that we've seen in the past. So, an example of that might be things like imputation, which is how to use statistical methods to calculate what we do for columns with missing data. Or things like oversampling, undersampling, things like one-hot encoding to handle categorical data. Because if we don't pay attention to how we're going to transform these things, then ultimately it's going to be a garbage in, garbage out scenario. So in addition to knowing the algorithms and knowing the way we want to transform our data, we also need a lot of modern tools that can scale and perform well. So tools, very common tools are things like AWS Glue, for example, and AWS EMR, which is, if you're familiar with it, which is based on a distributed computing platform called Spark. And for the most part nowadays, a platform like Spark is programmed using Python, for example. So many of these pipelines and transformations are done by developers writing Python code, ingesting this data into a large, elastic, scalable, distributed computing platform to operate on scale, and then doing all sorts of these sophisticated kinds of transformations and cleaning and scrubbing and prep. The machine learning parlance is called feature engineering. That is the big thing. You might have heard that term before. And then ultimately, all of this data, when something like Spark gets done with it, it dumps it all out into some kind of object storage, usually S3, which is commonly used as the basic for many data lake architectures. And then once it's in there, it's now available for any downstream system that would like to ingest that and make those data sets part of their own working data sets and data that they're going to then expose to their actual students and teachers and other kinds of users.
If I can add a level of complexity onto this, which is already plenty complex, Phil, you're talking about best practices for data management and data cleaning, and Russ, you mentioned interoperability, but those things need to be informed by insight, by understanding that these data were created as imperfect representations of what was going on in somebody's head. So as we make changes, as we patch gaps, as we do whatever with the data, we still have to understand what that means in the context of we're trying to improve this person's understanding. Accuracy rate or whatever is an imperfect representation of comprehension. So we need to make our decisions with that in mind, and that is not a trivial thing. The best data practices, the best data cleaning, all of that needs to be fundamentally sound in terms of why are we doing the things that we're doing. Because if that foundation isn't there, we're going to have a very, very tidy pile of garbage.
A tiny pile of garbage. I love that. Jonathan just put a comment in about, and I think he's with Thought Cafe. They just put in thousands of vector art and animations to their YouTube channel, and they're getting to the walk phase. And, for me, data being in a text form seems manageable. But when you start getting into video and animation and vector art and stuff like that, it's like, how do you even wrestle that beast to the ground and, not have a very tidy pile of garbage? That's a great quote, by the way. Anybody want to field that, or Russ is gonna?
No, I mean, I think again, it also depends. So reading that as I see, and I thought he said wall phase, like he ran into a wall at this point, which a lot of our customers do when they're starting. But with regards to the walk phase, I mean, recommendation, they're only as good as how often they're being used, the context of when those vector images are being used. And so, like, for instance, if you're creating some sort of presentation and it can read what you're writing about and then recommend at that point in time, you're searching for a vector image. You could then implement it into, say, a presentation or whatever that might be. And if you're capturing that clickstream data, that should start to inform your recommendation model as well. So like we're seeing a lot of people use AWS recognition as well. Recognition, you can upload images and it can give you with a percentage accuracy of what those images are as well. So you're able to then say, all right, I'm able to take this just massive amount of data, throw it through recognition, and get ideas of what that image actually is. So you don't have to pay someone now to create the metadata for each and every object. You have a starting point. Then you start feeding it in, you start getting your clickstream data, and you combine the two, and you're able to make recommendations. So it's definitely an area that we see a lot of customers doing, again, because we already have all this stuff before anyone even thought about putting in the plumbing for data. So that is another thing that we oftentimes have to work with our customers on that walk phase, is putting the plumbing in place that should have been there from the beginning, but oftentimes wasn't.
Yeah, I was going to sort of roll back to Drew. How is the data unlocking education technology solutions?
So not by itself. The data that are being created are largely speculative. You know, we know that they have a ton of value, but we also know that we haven't gotten the full measure of that. So we are protecting the data, and we're trying to build interesting things, but we also have to consider the rights of our users. So especially when you're talking about elementary education or under 18 education in the US, they have some kind of stake in that. And we don't really know how we're going to handle this, how we're going to navigate avoiding harm, essentially, because we know there's value in these things, that there's heavy investment from both industry and from government. The National Science Foundation is all over this. The Department of Education is trying to get more involved. So how are the data changing things is going to inform how we handle the data in terms of like the legal ramifications. And we are really just kind of wandering into what is still really the Wild West, where the data reside and what we can do with them.
Yeah, one of the other questions that pops up in a lot of my, technology business conversations is bias, and sort of, you're doing various things with data, assuming that it's credible and everything else, and then it turns out it's biased. And where do you think the challenges are there, and how do you sort of firewall yourself from them, or at least try as hard as you can to avoid them?
So awareness is certainly the first step. This is an incredibly difficult problem because we have the opportunity to democratize education worldwide. We have that. We are on the verge of that being a possible future, or we could just replicate what we have more efficiently, which has the potential to make our existing biases just worse, or to institutionalize those biases more than they already are. And it's not as simple as just like stripping out identifiers. So if you like take race out of the identification of a body of students, we have what's called the reconstruction problem, where the AI, especially if it's unmonitored AI, is just going to reconstruct factor X. It's not going to label it as race, but it's going to use all of those things that, because of the institutional biases that exist already, it'll recreate that, and then it will have kind of the blessing of being race blind. It'll have the blessing of being automatic, scientific, whatever. But we haven't done anything except for replicate what we already know is an unequal system. That is not something we could have spent the whole webinar asking that question alone, and we would have gotten nowhere close to a real answer to it. We are trying to put some meaningful barriers in place I've just finished editing a book that's about artificial intelligence from that human perspective, and fully a third of it deals with education. And another third is on decision support, which has the same kind of biases and dangers. So we are very concerned that the influence of automating biases is going to undermine all of the transformative and democratizing influences of the educational technology we're all trying to produce.
I was going to kick it to Phil. He looks like he's got some thoughts on that.
Well, I was going to say it's a great question. As a matter of fact, for those who've been interested, both Drew and I, along with Ed and Think, the last webinar we actually did cover just this topic. We did an entire webinar on bias and fairness in this space, and everything Drew said is I think it's really vital, because this is going to become, I can see this becoming the biggest topic as the amount of data collected grows and grows and grows. And to Drew's point, I think that the key thing is being aware of the problem, and then understanding some of the ways that we can not eliminate it entirely, but mitigate it as much as possible as we can. And it's on I can think of two of the systems that I've been personally involved in at this point, where we've been doing quite a lot of work on this. And one of the, on a more technical side, one of the tools that we've been leveraging quite a bit is a tool from AWS called Clarify, and it's Russ, you might be familiar with that. It's part of the SageMaker set of tools. And what Clarify does is it actually uses some very sophisticated statistical and deep learning algorithm of its own to help determine what kinds of biases your data set is exhibiting, and ways that you can help eliminate some of that, whether it's through some of the techniques I mentioned earlier, such as undersampling or oversampling, or some more sophisticated feature engineering techniques. But the fact that we even have tools like this now available to help this problem at scale, because to be honest, a lot of the data sets that we're working with, they're too large to just kind of look at by eye and say, oh, there's obvious bias here. We're talking about data sets that in many cases we get into hundreds of millions of billions of records, and no person or group of people is going to be able to tackle things at that scale. So it's important that we have vendors like AWS that are making tools that are able to help us tackle these problems, because that's where I see the future lying. And I think that space is only going to become more popular, and I believe that these tools are going, as the problem makes itself more aware, I believe these tools are going to become more sophisticated, along with our data engineers and ML practitioners awareness and bag of feature engineering tools and techniques that they can use along with these tools to help mitigate the biases as much as possible in our data sets. So yeah, very, very important stuff.
Russ, any comments on that? Or you just want to take the fifth?
I was going to say Phil is an expert in this space, going deeper in the engineering side. So I focus a lot on the business development side, but it is something that just the services and how we're continuously improving the AWS services to help solve these issues is important as well. So I won't get too deep into this. Andrew and Phil are more experts in this field than I am.
I'll make one little comment on it. It's like, I think it's important for organizations to avoid focusing on the easy data. Like the data that's readily apparent is often biased, and you got to work harder. You got to go, okay, well, we got the easy data. We've got to go get the hard data to balance it. And that becomes the trick, in a lot of these different sort of situations. It's like, and as an engineer, I'll give you an example. You know these oxygen sensors that are big during the pandemic? I actually worked for a company that made them back in the 80s. And they did manufacturing, everything else. And it turned out it only worked on white males. And the entire engineering team was white males. And we were all testing it on one another. I can remember. And I'm like, that was the easy data. It was readily available. And getting, we're in Baltimore, getting the data out of the underserved community schools is much more challenging than the affluent schools. And but you need it all in order to do that stuff. And in the corporate environment and enterprise environment, it's a whole other set of challenges because some people are not motivated to give you the data, but you as the enterprise really want that part of the equation. So
I like the way you put that about finding the difficult data, because we need to keep a research mentality. There's a temptation with such powerful tools, particularly machine learning, but really any kind of big data analytics, that the data are going to take care of themselves, or they're going to take care of my problems, or we just let this run loose. And we need to keep a really close eye on that. And it's not just about it being ineffective or inefficient. It is about avoiding doing very real harm, because this is just a tool. It's not magic. And we need to understand deeply the ways in which it works and the meaning, not just the data, but the meaning behind what we're doing.
Yeah, it really is going to be sort of the big challenge of, education going forward. Like if we want that, really great result of great education across the board, we got to work hard. It's not just going to be a technical solution. It's going to take a lot of different things. One of the other things, to get a little bit more boring about it, and I was going to throw this out to Phil to start with, is a lot of these EdTech platforms are in multiple different silos and old systems and legacy platforms. And, how do you roll that together? How do you, use different tools to create a holistic answer out of all these disparate sources?
Well, that's a great question, and it covers a little bit of some of the things we've been talking prior. Is that integrating a lot of these older systems is not easy, just because of the black box nature of some of them. And it's very difficult, and not all of them. The key thing here is open standards and protocols, right? Making sure that the systems we're using and the data we're using support these things. So whether it's something as simple as JSON, which is just a simple text format that almost every system under the sun understands at this point, or more sophisticated, or as you see in big data, more sophisticated file formats, such as two particular formats come to mind: Avro, which is a record-based format, and Parquet, which is a columnar-based format. But it's making sure that we're using these standards and we're leveraging them wherever possible to make sure that we're maximizing the opportunities for interoperability between these systems. And a lot of it, unfortunately, the reality is that in many ways, most of these systems that exist today, they're not going to talk to each other, just through historical inertia and just they just weren't built at this time. So really, what it comes down to is, in many ways, it's up to the vendors in the EdTech space and the developer firms and companies to be able to put together layers on top of these systems that can take all this data that are in these systems and consolidate that. And then that goes back into what I was saying earlier about consolidating this data into something like a Redshift or S3, which is powering a data lake somewhere. And then having on top of that, the real value add, the tools and the dashboards and the UI that then people can access and see the consolidated views of how all this data is working together. It's very unrealistic to, for example, believe it or not, a very popular platform in education is Salesforce. A lot of
Really?
Salesforce is used for things like textbook contracts and school board contracts and things like that with a lot of ed techs. And I mean, it's tough to name names, but Salesforce, it's not bad when it comes to interoperability, being able to get data into it and out of it. But ultimately, we need more sophistication than just a file export. And being able to take that data that's sitting in Salesforce and be able to integrate that into a meaningful way with our learning management system, or as Russ was saying, the platform that's building out recommendations for our students, it's it's a pretty thorny problem, and it's definitely going to, as an intermediate step with where we are right now, it's going to definitely require custom development, from ed techs and from ISVs, because right now, legacy systems, they just don't do that in the capacity that we would like.
Well, so not to get too far into the weeds, but like when you have these monolithic systems and you just like pump all the data into a central repository, you can, align it and scrub it and everything else. But then in the education system, you have all these different issues about personal information rules and aggregation, and these people can see this.
Sure.
We just had an issue in Baltimore, I don't know if you know this, where there was a whole bunch of grade changing done by the city school system at numerous schools, like thousands of like 58s were turned into 60s. So it was a passing grade. And it's like, how is that even? Oh no, I won't get into the Baltimore City issues at the moment, but that when you're dealing with education about kids, you have a lot of issues about who can see what. Short story.
Right, and the reality is that question opens up a huge can of worms under the umbrella of security. And as we collect all this data and as we integrate it with systems and as we expose it to students and teachers alike, we need to make sure that whatever solutions we're building or providing as practitioners, that they're secure, and that the security is again, as I've kind of mentioned with a couple of different things, it's not this bolted on afterthought to the system. The security is woven in from a holistic standpoint, and it's an organic part of the foundation of these systems and tools that we're building and providing. And there's a couple of key pillars with security that we need to make sure. And one of them that you mentioned and is super important is the idea of authentication and authorization controls and mechanisms. In other words, who is this person? Is he who he says he is? And what is he authorized to access? Can he access grades? And then can he only access them? What kind of permissions does he have? Can he access them read only, or can she edit them? So those kinds of controls and mechanisms are incredibly important. And then getting back to the PII data, the personal information data, how is that data scrubbed and how is it encrypted? Are we making sure that it's encrypted at rest? Are we making sure that it's encrypted in transit? What are the, and using something like most of the cloud native services, we know that the encryption rhythms are state of the art, and they're doing what they're supposed to be doing, as opposed to a lot of systems that were on-prem like 10 or so years ago, where a lot of those encryption algorithms are now no longer considered to be secure, and the kinds of things we want to tend to stay away from. So we have encryption, we have authentication and authorization mechanisms. We have to have tools in place to make sure that our PII data is scrubbed so no one could accidentally identify a particular person. And with and this is kind of jumping ahead a bit, but many kinds of these systems also specific. Some of the big ones, there's registrations and there's signups and there's tiered plans, and sometimes there's financial transactions involved as well with some of these systems. Maybe you want to purchase take a lot of online education, you want to purchase a course, so to speak, right? So there's, once you get financial data involved and any kind of financial transaction processing involved, now there's PCI compliance and all the security associated with all of those. So security is a massive topic, to your point, Ed, and it's something that we need to make sure we're spending the absolute maximum amount of time on it that we have available, to make sure we don't have what happened in Baltimore, or any kinds of, we hear about all the time. Oh, there was so-and-so had this massive data breach. 100 million records were compromised, right? And no one wants to be on the engineering side of that situation. It's not a good place to be.
So I want to do a time check real quick here and mention to the folks that are watching, now is the time to throw your questions in the chat area, and we're happy to field those questions. And then I was going to kick it back to Drew, this whole question that we're talking about here. Any thoughts from a more abstract policy perspective on that?
That's an awfully big question. So I'll reiterate that we just need to maintain need to keep our researcher hats on, because we are in a largely unregulated domain, because we are using data that we recognize as powerful, but not necessarily everything they can do, because we have these tools that are much more powerful than we have the human capacity to understand. Machine learning is by definition more complex than humans can understand. We have to approach these problems mindfully and not just throw a bunch of data at a problem and take that as the solution. Okay, the machine told me to do it, then that's what I'll do. Because efficiency isn't necessarily justice, for lack of a better word. It is cold, it is calculated, but it is not necessarily the best solution. So keeping those bigger principles in mind is tough, because I started off saying we're kids in a candy store, and we are, but we have to keep our responsibility in mind.
Yeah, I'm going to editorialize a little bit here for a moment. I think that we are a little bit ahead of our skis on this stuff, because we have these tools and we have this data and we have all these different school systems that have various rules and regulations and sort of stuff, but we don't have any overarching sort of sort of mission intent or guidelines like thou shall not, all we have is sort of things that are from other industries about personal information and everything. So it's one of these areas that occurs when technology gets ahead of, sort of established codes and best practices. And, I hope it catches up quick. I hope folks start thinking about it fast, because the data is really powerful, and used for good, it'll be wonderful. People doing things poorly will cause bad results, and I hate to see that taint the good stuff, But anyway, one of the things that I wanted to do is talk a little, leading that into the machine learning and how that specifically is making things easier or making things more difficult in the current situation that we have right now. with the tool set from AWS and the challenges from the different school systems?
Well, I guess I can take that as someone who's implemented these tools at scale on a couple very large systems. Um, there's no doubt about it. If you're going to go about put in the due diligence, they're going to make your life much easier. And I think the reality is, this is something I wanted to bring up earlier when we were talking about bias and data and staying away from the easy data. Well, we worked with a small. This was actually a small startup EdTech firm, and they had a unique problem. It was how to detect bias if your data set consists only of video and audio, which is it's a very interesting problem, because most bias detection algorithms are meant to just look at tabular data or text data or things like this. But here we didn't have any of that. All we had was video and audio. 50,000 video clips, a couple 100,000 audio clips. How do we determine if there's bias in this data? Not easy. And our solution involved a lot of the AWS tool chain, specifically some things that Russ mentioned, things like transcribe and things like big kudos to Recognition, which is an ML video service. And I can't imagine, and I've been in this business now for about 27 years or so, and I've had the fortune to be the chief architect for two of, if not the largest two K through 12 and graduate platforms that are out there. And I can't even fathom the idea of you wanting to do solve this kind of problem starting from scratch. It'd just be impossible. You would, because ultimately these products need to be useful. They need to work. You need to actually get them into production and get them running. And if you're starting from scratch, it's going to probably take you 10 years to do something like that. Whereas being able to leverage a lot of the tools that are out there and that AWS is kind of commoditized for us, it gives everybody a massive leg up. And I don't have to employ a team of 30 or 40 PhDs who have done nothing but this kind of specialty area for the last 20 years of their career, which is not something that's going to happen anyway. So that's one actual, real world kind of something that comes to mind where they were very beneficial. And another thing that comes to mind is a recommendation. I know Russ has mentioned this several times, but it can't be. I don't think it can be said enough to how useful a recommendation system can be. A recommendation engine can be. A lot of people tend to think of recommendation systems. They tend to think of Netflix. Oh, it tells me what TV or movies I want to watch. Or Amazon, it tells me what kinds of things I want to buy. The reality is that a recommendation engine in and of itself, it really doesn't care if it's movies or golf clubs or whatever. It just takes the data that you have, and then it does some sophisticated things to it, and now it pops up hey, this data somehow correlates with this other data. Maybe this would add value to somebody, which is all it does. So we've been able to leverage that to help students quite a bit in terms of the kinds of things that, making recommendations on the kinds of things that they should be focusing on, learning with, the kinds of materials that might make sense for them. And at graduate level, we're building out a recommendation system that can match grad students to the best prospective grad programs for them based on a variety of data points, to make sure that they're, because time is of the essence here, right? And we want to make sure that each prospective student is applying to the programs that make as much sense to them. So using something now that was a little bit more sophisticated. We weren't using AWS Personalize for that. We were actually using AWS SageMaker for that. But even so, the leg up it gives you and the amount of bootstrapping it gives you is it's just tremendous. So yeah, so these things in the real world, they really do help. And I kind of encourage everybody to don't do it yourself. You use these tools and incorporate them into your solutions, because they're going to give you a lot of bang for the buck, and they'll allow you to get to production and value much faster.
Great insight, Phil. Excuse me, I got something in my throat. Laura's giving me the signal that we're like rolling down to the last minute. Andrew and Russ, you want to do a 30-second last thought?
Sure. I'll quickly go. I mean, to Phil's point, just like he said, a lot of these services that you could just turn on or turn off and have years of pre-baked models in, you don't have to start from scratch. You can do a lot of those things. Same with, you want to leverage a BI tool like Amazon's QuickSight. You can put data in, you can start building visualizations. You don't have to sign long-term contracts. That allows that democratization of being able to do things with AI and ML and data so quickly and easily. And I help our ed techs all the time. So if it's something that you just want to kick the tires of what's next, happy to ideate with you guys and figure out how we can help you grow and scale, and work with Phil and others to help you build that.
And I'll just say again, this is a very exciting time to be in educational technology. And we should, as Phil pointed out, use the lessons that were learned from other domains, from other applications. But as with pretty much everything else in education, it's just that little bit harder. The value of Netflix's recommendations or Amazon recommendations is whether the customer then did the thing. In education, it's whether we improved their mental model of the thing we're trying to teach them. And that's a lot harder to measure. We can't get that necessarily with a click. So it's just going to take some diligent effort, some very smart people working with that researcher mentality in combination with some very powerful tools and services.
So one quick note, Andrew Hampton mentioned the ethical considerations and practices group on IEEE. I think that's a great sort of like answer to the question, but there's a lot of work to be done there, and I think it'll continue. And I wanted to let everybody know that there's a recording of this, and I really want to thank Andrew, Russ, and Phil for sharing their insights. And if folks have follow-up questions, happy to connect and keep the conversation going. I didn't even get to my whole thing about like a Stack Overflow crowdsourced evaluation of like test data or student information and essays, but maybe next time.
Thanks for having us.
Thanks a lot.
Thank
Have
you,
a good
Ed.
rest
Thank
of your
you, Laura.
evening.
It's been a pleasure. Have a great evening, everybody.